Assalamu alaikum to the lecturers and doctors who is watching this recording. Today, I'm to present my thesis on the experimental investigation on the wind pressure distribution of modified building shape using wind tunnel test. Before that, I am Azri Arif bin Mazlan, matrix number 1626905 from the Kuliah of Civil Engineering. So, for an introduction, the modern era is influenced by the architectural design of the buildings in all particular country. Uh, the more complex and more irregular shaped your building is, the more developed your country will look. That's the main fact of the modern era. So a lot of architects uh, they try to make buildings which are, you know, not of basic shapes. There, there's twists, there's helical shaped, cone shaped. The corners are modified. So as I attached here, here's a example: the Kayan Tower in Dubai, which has a helical twist on it, which really is aesthetically pleasing. And then on the bottom left, we have the TRX Exchange in Malaysia. Uh, it is actually a tapering shape, and then next to it is the Menara Tabung Haji, which has a slender shape to it. So all of these are uh, really showing the modernness of the country itself. But the problem statement is that irregular shaped buildings, uh, they are not accounted for in the code. The code only accounts for basic shapes. So we can take a case example, which is the tragedy at Jalan McAllister, which involves a 200-ton fin structure of the UMNO Tower. So what happened was there was a huge thunderstorm, strong winds were blowing, and the fin it couldn't really sustain itself through this really large wind load, so it fails and it crashes down in 21 stories. So what happened was the road below was devastated, and one life was taken. So this is actually due to the incompetence of the engineer, who does not take into account the irregularity of the building shape. So because of this case, right, the investigations on the distribution of pressure on modified shapes should be deepened so that more accurate wind analysis on buildings can be obtained, and also the improvement of the code itself so that it could actually take into account and considerations of buildings that are of different shapes. So the objectives of this study is to analyze the wind pressure distribution to a structure with a single modification to its base shape. Next is to find out the changes that accompany the wind pressure distribution when applied on a structure with a single modification to its base shape. And lastly is to perform a simulation of the predicted wind pressure on modified structure with the use of wind tunnel tests. So what I've summarized from the literature review is the uh, preferred modifications that were implemented by different authors on their basic shapes. So as you can see here, the most common shapes that were chosen by the authors are square shaped and rectangular shaped cross sections. So like we said, uh, these two are the most popular shapes between these sets of authors, and they implement so many modifications on them. For example, Kim and Yu in 2002, they made a tapering modification on their basic shape. So tapering is basically It's like from the original shape, it just goes slender. It goes more bigger in the base, but it goes more slender as you go uphill. So Kim and Kanda also made a tapering modification. Then you can see Kwok, Kawai, and Elshar et al. They made a corner modification to their basic shape. Then there's corner mitigation and helical twisting shape by Elshar, and a 360 degrees helical tapering and chamfered corners modification by Kim et al. In 2014. And then the next set of authors, they made modifications on rectangular cross-sectional shapes, and most of them, they had a modified side ratios for all those shapes that they chose. And it's interesting to see that most of them, they opt for wind tunnel tests, and only two sets of authors uses otherwise, which is CFD, ANN, and computer-aided numerical studies. So for what I chosen in comparison with previous works is I chose a square-shaped cross-section model with a corner modification. However, what I chose was different from the sets of authors that used corner modifications. As you can see here, they used chamfered corners, slotted corners, and rounded corners. While for this experiment that I'm doing, I'm using a corner cut model as shown in the figure below. You can see the 2D view and the 3D view. So in this investigation, a wind tunnel test is also utilized, just like the majority of the previous authors. So here is the proposed methodology that will be used in FYP2. So at the start of the next semester, we will have all our models and wind tunnel tests planned. Then we have to prepare the model, setting up the model in the wind tunnel, running the wind tunnel test, collecting wind pressure data on model, then having results and discussions with people of higher knowledge, supervisors, and then having our conclusions and recommendations. So for the preparation of model, we have a scaled down model of 1:250 with a base shape of 120 mm, 120 mm. So this base shape is then modified into a corner cut model as shown in these two figures below. So in conclusion, in this FYP1, I have achieved my objective of trying to prepare a model that is resembling the case study, which is the Amno Tower's failure. So the previous works that I have summarized and go through meticulously with much detail has given me a more detailed understanding and an insight on the effects of shape modifications on the buildings. So because of that, it gives me the idea and initiative to take the square shape and a corner modification that was not made by them before. So for final year project 2, I will utilize the wind tunnel test to determine the wind pressure on the chosen shape modification, which is the corner cut. So the results will be taken, discussed, and documented. So after that, improvements will be suggested for future references. So now is the Gantt chart representation for FYP2. So we have preparation of data, which is the start, finalization of model, commencement of wind tunnel test, tabulation, discussions, conclusions, and then submission of full report. And I estimate that all this will take the whole semester to complete, which I have allocated the respective dates for each and one processes that I've listed here. So that is all on the presentation of the chosen topic. So that's all for me. That's all from me. Thank you.